Hello, lovely people, and welcome once again to this amazing playlist of solutions of the great book, The Problems in General Physics, Irodov, and how to crack these solutions, how to crack the answer, how to take the answer in our mind and write it on this solution book. So let's focus today on question number three. Three, right over here. What the book is doing here? Let's keep it here. Let's focus on the question. Well, the question was right from the book. So let's focus on the question first. Uh, this question seems to be interesting at first, and it's also a very simple question in this book. So after reading such question, what's come in my mind is to draw a graph, draw a perfect graph. So let's first read the question. Question 1.3 of this amazing book, guys. Question 1.3 of Irodov, Problems in General Physics. Here as follows: a car moves rectilinearly first with acceleration. This sign over here is W. In our general books, we write as A. This book, Problems in General Physics, has many fancy terms like this. You will see gradually in your course. As acceleration is equal to 5 meter per second square, the initial velocity is equal to 0. Then uniformly take a look at it carefully. This is the key term here. And finally, deaccelerating at the same rate W comes to stop. The total time of motion equals, there's another fancy term here, T. I will just pronounce it. Capital T is equal to 25 seconds. The average velocity during the time is equal to another fancy term. This fancy term relates angular brackets V, then another angular bracket is equal to centimeter to kilometer per hour. It's simply as the same as the average velocity of this car over the whole period of time. How long does the car move? Uniformly, as I've said earlier, uniformly is the key term here that opens a lock to solve this question. So the first thing that came in our mind after reading such type of question is to draw a beautiful graph of this question so that we could straight away do the question. So let's focus on the graph first. The first point is that a car moves from initial velocity 0. So I think I should put over here V. This pen's not working. Y-axis is V. Where is the V going? V. And this is T in seconds. And this is in meter per second. So here guys, here's a graph and we'll plot it at an interesting way. So first it goes to a point A. Its velocity changes at the rate 5 meter per second square, starting from right off from 0 to somehow this point over here. So let me draw this point. Yeah. Then it moves for some time uniformly to reach at the same velocity over here. It goes on with time, velocity doesn't change with time over here, and then it gets down decelerating at the same rate as over here the previous condition. So this is a whole graph, a nice and neat graph for this question over here. This is the acceleration, this is velocity in y-axis, this is x-axis, and let me draw some lines perpendicular, dotted line I would say, perpendicular to the x-axis over here. And this is the graph that will give straight away our answer to this perfect question over here. And let's guys focus on the question and let's take out the answer out of it. So as we know, and let me write a note over here. First note is that if something here is car, my hand is getting in front of the camera guys, so let me keep my hand away from the camera. If something is accelerating at a rate W, sorry for the handwriting, for time T over here, I will say T, and then it deaccelerates at the same rate. At the same rate W, then it would take the same time T from going from this velocity to the velocity V naught over here. So it would take same time that's equal to T to get the initial velocity in which we have started. I don't have to write it. In this case, the initial velocity was 0. So let me imagine the time taken for this journey to be t, for this journey to be t, and this whole over here right from the beginning for coming back to 0 was 25 seconds as for a question. So what about this? What time do you think that it would take in this part? Well, focus. This is 2 into time over here, and this whole is 25. So it's simply 25 minus 2t over here. Right, guys? I think you are getting the solution. I think you would do it now as the question has become very easy over here. So, for doing this question, our average velocity is given over here. Average velocity is given, that's equal to 72 km per hour. Okay, it's kilometer per hour. We want in meter per second. What is going over here? So let it simply convert in meter per second by multiply by 10 by 36 or simply 1000 by 3600, and that gives 2 into 20 into 10, sorry, that's 20 meter per second, our average velocity. We know that average velocity formula is total distance, path distance I would say. It could also be, we can say displacement in case of everything. We could say distance if the motion is in a straight line upon total time. We know the total time is 25 seconds. We know the average velocity is equal to 20 meter per second as we have converted from kilometer per hour to meter per second. So we can just find the total distance in terms of these t time over here, and we could get the value of t, and we will simply substitute over t over here, and we will get our uniform motion time over here. So let's simply focus on this question over right over here. So let's think about the distance traveled by the car from O to C on the graph. From O to A. First, we write distance from O to A will be equal to, we know this formula that S is equal to initial velocity into time plus half at square. The S would be over here. As the initial velocity was 0, we would simply substitute a 0. It would become 0 over here. 1 upon 2, our acceleration is 5 into t. This is our S from O to A. Now S from A to B, second case, S from A to B will be equal to initial velocity over here from going from O to A would, or to O to A, sorry, would be simply equal to 5t. As you can imagine that V final velocity is equal to initial velocity plus acceleration to time. So our final velocity would be equal to 0 plus 5t, and that's equal to, so we will simply write over here that its initial velocity was equal to 5t over here, and for what time it has traveled, for 25 minus 2t, and that was equal to 25 minus 2t over right over here. And third case is as going from B to C over here, and that we will write simply it as B to C, and as this motion was uniform, the velocity doesn't change, it would remain the same right over here, that's equal to 5t. So our initial velocity 5t right over here, for time of the acceleration, and it would be 0 after t seconds. As considering this note over here, it would be t minus half 5 t square right over here. Now if we add these quantities, we will get the total distance. Total distance of car is equal to 1 plus 2, I think it's not clear, plus 3 over here. So let's add them together, and what we'll get answer as 5.2t plus simplified value here plus, what's 25 into 5, 125t minus 10t square plus this value 5t square minus 5 by 2t square. This cuts over here. It was a square right over here, right? This would be a square. The value is ut plus half at square, so that would be squared minus square, and this gives our total distance as minus 10t square plus 125t. That's our total distance. And if we can say the average velocity was equal to 20 meter per second, so 20 meter per second into the time 25 second would be simply equal to minus 10t square plus 125t right over here, and this was equal to 500 is equal to minus 10t square plus 125t. That could simply put on LHS side to simplify our problem, as 500 is equal to 0. We will simply get it right over here, divide by whole equation by 10 and we'll get, sorry, 5. As this thing's gonna be messy, there was also some sort of plus 5t square over here. So our question, this was wrong. This went wrong actually, as it was plus 5t square over here. I've neglected it. What's the circumstances? Someone was knocking on the door, so I was just confused a little bit. So we write it simply as plus 5t square, and this was equal to 500 minus 20 square plus 5t square minus 5t square plus 125t. Putting the values in LHS for simplifying equation, 5t square minus 125t right over here plus 500 is equal to 0. Dividing the whole equation by 5t square minus 25t plus 5 plus 100 is equal to 0. Now let's simplify it. T square minus 20t minus 5t plus 100 is equal to 0. We can get, let me turn over the page, we get t minus 20 right over here minus 5 t minus 20 right over here is equal to 0. So equation was t minus 5 t minus 20 is equal to 0. We can take t is equal to 5 or 20. So what value should we pick over here, 5 or 20? That's an interesting approach. We know that the total time was equal to 25 seconds, and this over here is t, means if we take it at 20 seconds, this to 20 seconds, then it would be 40 seconds, and this would mess up our question as total time is given to be 25 seconds. Let me calm down. Right over here. So we should pick a value that would match our question. So we'll pick up t is equal to 5 seconds. We will neglect it over here. So we have taken, let me make it more clear, t is equal to 5 seconds. And what's this statement over here, this uniform motion? We would simply simplify time for uniform motion. We had taken it equal to 25 minus 2t. We would put the value of t is over here 25 minus 10, which is equal to 15 seconds. That's our answer to the question right over here. That simplifies our graph right over here to this simple answer, 15 seconds over here. And this is the beauty of physics, right, that we have seen. This simple graph has different meanings over here, it has different aspects over here, and this gives a single answer that's equal to 15 seconds, and that solves our question. Please review the answer once again so that it could be understood in a right way. Thank you guys for watching this video, and let's focus on the next solution, this book, right? Care for yourself, be wise, be thankful, and let the competition begins. Thank you.